All right, we're going to get started here in chapter 3, talking about integers. And specifically today, we'll talk about integers and absolute value. But before we get started, I'd like you to work here on page 190, and you're going to do number 1, number 2, and number 3. All right, you're going to work on those 3 problems. So pause the video and see if you can reflect back and do the order of operations to solve each of those. All right, let's see how you did here. Remember the order of operations, parentheses, exponents, right? And then multiplication and division, those are grouped together because you do whatever one comes first as you read the problem left to right, and then same with addition and subtraction. All right, so we go through the order of operations. In number 1, we do the parentheses first and get 9. So we'd have 54 divided by 9. Should have gotten 6 for our answer there. Number 2, starting with the parentheses, 10 plus 50 should be 60. Divide by 5, you get 12. And then number 3, a little bit longer of a problem here. We start with 4 minus 1 in the parentheses. So that gives me 3, right? So then I have 2 times 3 would be next, right? Because multiplication comes next. So that gives me 6. 18 plus 6 should be 24. All right. We're going to skip out on the coordinate graph. Remember, you got your Turkey for those in-person learners. You had the Turkey grids that you can work on to practice your coordinate graphing. All right, let's scroll down to page 191 and introduce a term called integer. All right, and integers are both positive and negative whole numbers, right? And whole numbers would be like 0, 1, 2, like no parts, no fractions, no decimals. An integer adds the negatives into that set, right? So negative 25 is an integer. Negative 4 is an integer. 5 is an integer. 0 is an integer. So if you want to describe it right here, maybe we can say both positive and negative whole numbers. Right? I mean, we're not going to have any parts to it. There's not going to be 10.5 or 2/5. So if we list some non-examples, right, we can list anything that's a fraction, right? A half, 0.7, 2 and 2/3, right? These are non-examples. These have parts to them. Some examples would be negative 5, negative 3, 0, 27. I could even have 6 over 2, right? I don't want to say like all fraction, right? Because 6 over 2 is really 3. That's a whole number. There's no parts left over. So integers are all of the whole numbers, both positive and negative. All right. And what we're going to look at in this chapter is we're going to look at what happens when we add, subtract, multiply, and divide both positives and negatives and a combination of positives and negatives. And so the first thing I want you to do, this right here says picture it. This is a number line, right, where I have 0 here in the middle. And then to the right of that would be all the positive values. And to the left of that would be all the negative values, right? The number line is going to be important to us to order numbers, right? Because if I can plot them on a number line and then just read them off left to right, that'll order them for me. And it's also going to help you with your understanding of the operations that we do, especially addition and subtraction. So what I want you to do now is on the agenda, I put a link to an interactive number line. So I'd like you to click into that link. And it brings up this number line. And we can say, let's start it at negative 25. And say, okay. So then we'll say done. So here's my number line, right? And it goes negative 25. And then if I want to, I can grab up here at the top and I can scroll to have it go to higher numbers. And if you want to set it lower, you can set it instead of -25. If you want to have that set lower, you can. And then it'll interactives down here, and we'll get to play with these more as we go. And it has a calculator there. But for right now, we're just going to use it as a reference. So pause the video here, and you can take a minute and pull that number line. All right, so after you have the number line pulled up, we'll go back to our books and look at page, let's see what that is, page 192. All right, so if you look here, it has a number line graph, right? And it says negative integers are any integers that are less than 0, right? And they're written with a negative sign. Positive integers are greater than 0, and they can be written with a plus sign, right? But notice that when we talk about positive values, we don't say the positive in front of it. And a lot of times the number is written without a positive. We'll look at some examples in just a second, right? But when I say 27, it's understood to be positive 27, right? If I want to identify it as a negative value, I would have to say negative 27, right? If I want to say positive 5, I don't have to say positive 5. I can just say 5. All right, so notice zero's in the middle. It's neither negative nor positive. And if you see here, we can label and plot points on the number line, and it uses we can use the number line to tell which numbers are bigger than others, right? And the further right it is, the larger the value. For example, if I have the numbers -5 and -2, right? -2 is further to the right, so -2 is greater than -5. +4 versus 2, right? 4 is further to the right, so 4 is greater than 2. And those positives are easy to understand, right? We got to start conceptualizing the negative values in there, right? And think about that as like owing money, right? I'd rather owe $2 than owe somebody $5. So -2 is a bigger value than -5. So let's look at modeling situations with integers, right? So here the average temperature of 5 degrees below normal, right? Since it's below normal, we use -5 to represent that situation. In example 2, it says the average rainfall is 5 inches above normal. Since it's above, okay, notice you could write it as +5 or just 5, right? When the positive sign's not written, it's understood to be a positive value. However, when it's negative, you have to have that negative situation there. So if we look here, it says write an integer for each situation. 6 degrees above normal. So above, right, I could say that's 6, or I could add that positive in there. 2 inches below normal, I'd have to represent that as -2. So let's scroll down into our practice examples. All right, and I want you to look at number 1, 2, and 3 and model those situations with integers. Okay, so pause the video here and work on 1, 2, and 3 from the guided practice. All right, so starting out, a deposit of $16, right? When we use the term deposit, that means that we're putting money in, so our bank account will go up $16, right? The term for taking money out would be withdraw. A loss of 11 yards, right? So we're going backwards, we're going left 11 yards. 6 degrees below 0, right? That would be below, that would be to the left, so that would be a -6. All right, getting into graphing each set on a number line, right? So we look here, we're going to do -2, 8, and -7. So -2, 8, and -7. We're going to graph those on a number line. And then we're going to look at -4, 10, -3, and 7. So one way I could do that, I could just draw my own number line. Right, and I put 0 in the middle, and then I could say here's -1, 2, 3, 4, 5, 6, 7, right? See how sloppy that gets? So what I'm going to do is I'm going to go to my number line here, right? And down at the bottom, it'll give me this drawing tool. And I can just plot these on here, right? So -2, right? I'm going to slide this over a little bit. +8, and -7, right? So if I were to ask questions about this, what's the smallest value out of those three? And I could see that -7 is furthest to the left, so that would be the smallest. The greatest value of those three would be +8, because that's the furthest to the right. Let's see if we can erase these here. All right, so we'll clear all those. The other set of numbers, if you're looking in your book, was -4, 10, -3, and 7. So -4 would get my drawing tool back up here. -4, +10, -3, +7. Right, and if I were to want to order these from least to greatest, I would start over here with -4, and then -3, and then 7, and then 10. So -4 would be the smallest, 10 would be the greatest in that set of numbers. All right, our next vocab term is absolute value. Okay, absolute value. And think about absolute value as a distance. Okay, it's the distance between a number and 0. And distance is always positive. Write that down. Distance is always positive, right? And if you think about it, if you run 4 times around the track clockwise, you've ran a mile, right? If you run counterclockwise around the track 4 times, you've still run a mile. You don't say I ran a negative mile. Distance is always positive, and that's what absolute value represents. So absolute value is always positive. And the notation for absolute value are just 2 straight brackets like this, and it's representing a distance from 0. So you can see the example they give here. The absolute value of -5 is 5 because it's 5 away from 0. The absolute value of +5 is also 5 because it's 5 away from 0. So no matter what, an absolute value changes the number to a positive or it keeps it positive. So if I were to say the absolute value of 3, that'd be 3 because it's 1, 2, 3 away from 0. The absolute value of -3 would also be 3 because it is 1, 2, 3 away from 0. So absolute value is just how far away in distance is it from 0, and which means distance is always positive. All right, so we're going to look at some examples with both just what is the absolute value of a number and then also using it in operations. Okay, so absolute value of 8 would just be 8. Right? It's positive, it stays positive. Now, in F, right, notice that it's 2 plus the absolute value of 3. So the first thing I want to do is evaluate the absolute value of -3. So really this problem would be 2 plus, and we should know the absolute value of -3 is 3. 2 plus 3 would equal 5. Here in example G, -6, right? Absolute value, right? So notice these straight brackets. That's absolute value of -6 minus 5. So the first thing I want to do is evaluate what is the absolute value of -6. Should be 6 minus 5. We get 1. Okay, so first thing we want to do is change the absolute value and then solve the problem. So let's look at some examples of those. All right, work on 4 through 7. Okay, 4 through 7 on page 194. Okay, so pause the video here and then check back to see how you did. All right, let's see how you did here, right? So it says evaluate the expression, the absolute value of -9. So really what these brackets are saying is how far is -9 from 0, right? And we should know that it is 9 away from 0. Number 5, absolute value of 18 stays 18, right? Absolute value of -10 is 10, right? So it'd be 18 minus 10, which should be 8. In number 6, right, the absolute value of -11, right, is 11 because distance is positive, right? It's 11 away from 0. And then the absolute value of -6 is 6. So I would have 11 minus 6 should be 5. Graphing the set of integers on the number line they provided, notice that they go by 2's, right? So positive 11 would be in between 10 and 12. -5 is in between -4 and -6. And then we have -8 there on the number line. All right, I want to talk about number 14. Okay, it says reason inductively. It says if the absolute value of a number, right, so this variable x, so the absolute value of a number is equal to 3. What does that number have to be? So I want you to think about that for a second. So the absolute value, that's asking me what value is 3 away from 0? Okay, what value is 3 away from 0? All right, if we kind of visualize it, here's 0, right? And the answer is going to have two possibilities, right? Because I could start at 0 and I could go 1, 2, 3, and that would be positive 3. Or I could go to the left, 1, 2, 3, and end up at -3. So there's two different values for x, both 3 and -3, that would have an absolute value of 3 away from 0. So a couple things to notice, right? When I write a negative number, I have to have that negative sign with it. When I write a positive value, it's not there. It's not wrong to say +3, but notice it's understood that if I just say 3 or 7 or 5, those are referring to positive values. All right, what I'd like you to do for your assignment, I would like you to work on page 195, and you're going to do numbers 1 through 9. Okay, you're going to work on 1 through 9. Once you're finished with those, you'll click on the next video in the agenda and check your answers. If you have any questions, shoot me an email. Hope you all have a great day.